A stream of water flowing horizontally with a speed of 15 meter per second gushes out of a tube of cross-sectional area 10 to the power minus 2 meters square and hits a vertical wall nearby. What is the force exerted on the wall by the impact of water, assuming it does not rebound? So the question is saying that the water on striking the wall is not rebounding back. So we begin this way, that the speed of the flowing water is 15 meter per second and the cross sectional area of the tube is 10 to the power minus 2 meters square. So if I write the volume of water coming out, so volume of water that is coming out from pipe per second can be written as A into V, where V is velocity. So if we calculate this portion, we obtain 15 into 10 to the power minus 2 meter cube per second. So now if we calculate the mass of flowing out water per second, so mass of water coming out per second, then we multiply it by the density of water, that is rho AV. So if we multiply it with density, so we obtain 1000, that is 10 to the power 3 kg per meter cube into 15 into 10 to the power minus 2 kg per second. And for this particular portion, we obtain 150 kg per second. So this is the mass of water that is coming out per second and striking the wall. So now since there is no water that is rebounding back, so we can say that the force is equal to the change in momentum by time taken. So the average force exerted can be written as the change in momentum by time taken, that is 150 multiplied by 15, where this is for velocity, and then we obtain it as 2250 Newton. So this is going to be answer for this particular problem. Since it is not rebounding back, so the final momentum is going to be 0.